aromatic ring, and the most common aromatic, there are many types of aromatic ring as you can see over here, which the most common aromatic ring I am writing here is Neha and Absaar, that is benzene. Okay.
Yes, sir.
Yeah, and if I remove one hydrogen and if I put one halogen, which can be Cl, F, Br, or I, okay, it is going to become a chlorobenzene. Okay, these are aromatic halides. Neha, is it clear? Okay, you can have aromatic halides like you can have naphthalene also. Okay, right? So various aromatic compounds are there. The other classification which you can have, Absar, is what is the other classification of alkyl and aryl halide? Any other classification you know? Primary, secondary, tertiary. What do you mean by primary halides? Yeah, Absar.
Don't know, sir.
Yeah, primary carbon is a carbon which is connected only to one carbon atom.
Okay.
So suppose if I put this CH2Cl, this is primary, 1 degree.
Yes, sir.
Okay. And if we have this, this is secondary. What do
Yes,
you
sir.
mean by secondary?
Has 2 carbons.
Yeah, the carbon which is connected to 2 carbon. Yeah. Neha, I think you got disconnected by mistake somewhat. Maybe.
Yes, sir. Internet issue.
Yeah, no problem. And this is tertiary. Okay, tertiary carbon is a carbon which is connected to 3 carbon atoms. Okay, and that one is secondary. Can we have quaternary halides? Can we have quaternary halides? Quaternary carbon is a carbon atom which is connected to 4 carbon atoms, right? But if we have carbon atom which is connected to 4 carbon atom, it means what? Can now we put any halogen on this carbon?
No, it's already connected to 4 bonds.
Yeah, it's already connected. It's already having 4 carbon atom. We can't replace any hydrogen. There is no hydrogen in fact here, so we can't have quaternary. Okay, this is quaternary carbon, but we can't have quaternary halides. Okay. Apart from that, we have one more classification, that is vinylic and allylic. What do you mean by vinylic and allylic halides?
Allylic halide, as in there are halogen atoms on allylic carbons.
Yeah, what are allylic carbon? Yeah, correct. Yeah, but what are allylic carbon? Actually, yeah, you can complete.
It's a carbon. The carbon has a double bond with another carbon, as in like CH double bond CH2.
Actually, the doubly bonded carbon itself is known as vinylic carbon, right? Absar and Neha, is it clear?
Yes, sir.
These are vinylic carbon atom, and if you have a halide connected directly to them, that is vinylic halide. Okay. But if you have a carbon next to doubly bonded carbon, carbon atom which is itself not doubly bonded, but it is just next to doubly bonded carbon, that is called allylic carbon. This is allylic carbon. And if we have fluoride, chloride, bromide, or iodide connected at this position, okay, and this is known as allylic halide. Is it clear?
Yes, sir.
Why we are classifying them? Because we will be needing this classification when we are going to do the reactions. Okay, that's why these classifications are important. That's why we need to classify them. Okay, vinylic, allylic Pvt, primary, secondary, tertiary Pvt. And we talked about alkyl halides and aryl halides. Aryl halides is the means aromatic halides. If you have an aromatic ring and the Cl or Br or I halogen is directly connected to the aromatic. Is it clear? So
Yes,
that is
sir.
known as aryl halide. Okay, vinylic and allylic Pvt. The next one is all these which we were discussed now is uh, they were monohalides. Monohalides means I have put only one halogen atom on them. Okay, I just put one halogen atom, right? So they were all monohalides. Okay, but we can have dihalides also, right? We can have dihalides. So dihalides can be classified into any idea? Neha and Absaar, how can you classify dihalides?
Geminal dihalides and vicinal
Yeah,
dihalides.
yeah. Geminal and vicinal. So that is, in short, it is written as gem. The complete name is geminal and vicinal. So geminal actually means what? Short is gem. Yeah, what do you understand by geminal? Means two same halogen connected to same carbon atom. They are called geminal dihalides. Okay. Not OH. And these are vicinal, right? Vicinal means they are in the vicinity. Is it clear? Can you write their IUPAC names? Can you tell me their IUPAC names also? Yeah, sir. Neha. We can try writing their IUPAC names also. Yeah. We need to select the longest continuous carbon chain. Okay. And depending upon the number of carbon atoms, we can give the word root. Okay, word root actually tells us about the number of carbon atom in the longest continuous carbon chain. Longest continuous carbon chain is of two carbon atoms. So what's the word root is?
Is the first one dichloromethane?
No, it is the one carbon. It is meth. For two carbon, it is eth. Three carbon, it is prop. Four carbon, it is but. Five carbon, it is pent. So which word root should I use? Absar, tell me. Yeah,
Ethane?
Myth, it, prop. Yeah, I'm going to use it,
Eth.
right? Because there are two carbon. It. So I have used it. And should I use in or ein? That depends whether you have single bond, double bond, or a triple bond. So can you see any double or a triple bond?
No.
No, all are singles, so I'm going to put ethane. Okay. And always remember the name of the halogens. The name of the halogens are written in prefixes. Okay. So what do you mean by prefixes?
The, the element that comes before the root word.
Yeah, that comes actually, prefixes means prior. Okay, just like in the book we have preface. Okay, so just remember that the name of the halides are written in prefixes. Absar, is it clear? Am I audible to you?
Yes, sir.
Okay, so ethane is clear till now.
Yes.
It,
Yes, sir.
ane is for single bond, and always the chlorine, the halogen atoms are written in prefixes. Okay, so we have halogen atom prefixes. There are two chlorine atom. Okay, so and where they are, how can we show them where they are? So we need to number the chain. Okay, numbering we do from the side which is nearest to the group, which is the subsequent or the branch which is connected. Is it clear? So I will do this numbering. This is correct. I will not do this kind of numbering. These numbers are known as locants because they are indicating the location of the groups. Okay. So this numbering is correct. Okay. Because the wherever the Cl atoms are connected, that is this one is giving lower number. Okay. So you start the numbering from the side which give lower number to the locants. Is it clear? So it is 1 1 di 1 1 means there are two chlorine atom. For each of them, you need to write their number. Okay, and if they are same, so you can write 1 1. And there are two chlorine of the same type, so I'm using the prefixes di, tri, tetra. Okay, so 2 means di, chloro, ethane. Is it clear? 1 1 dichloroethane. So Neha, I hope it is clear.
Yes, sir.
And what about the next one, Absar and
Yes,
Neha?
sir.
What is going to be the name of this one? The second molecule, which is a vicinal. Vicinal means on the vicinity. If the two halogen atom are adjacent to one another, then it is known as vicinal dihalide. Okay. So, what could be the IUPAC name of this vicinal dihalide? You can tell me. Apsara and Neha.
1,2-dichloroethane.
Yeah, it is 1,2-dichloroethane. Correct. 1 and 2 because this is having the same parent chain, and but the chlorine atom are on the adjacent carbon atom, so 1,2-dichloro. Right. So this is the IUPAC name, and this is one more categorization. So suppose if I write a mixed structure which contain all type of halide which we discussed just now. So you need to tell me what type of halides are we discussing right now. And there is vinylic, allylic, and there is one more, benzylic. Benzylic actually is just like allylic, but the carbon atom which is just outside the benzene ring, that is called benzylic halide. So this group, there is the benzene, not the benzene, not just the benzene, but there is a CH2 group just outside the benzene. And if you have an halide at this position, okay, this is called benzylic, right? Benzylic bromide. Okay. So yeah, you need to tell me what kind of halides are these. For example, the bromide is it aliphatic or aromatic or allylic or vinylic or benzylic? That you need to tell me.
It's aromatic.
Yeah, the one which is directly connected to benzene is aromatic. Aromatic halide.
And
Ar-
it's benzylic.
and it's
Benzylic.
which one?
The
Which one?
H2.
Which one is benzylic? The Cl or I? The bromide is not benzylic. Abshar, is it clear?
No, the Cl.
Yes, sir.
Yeah. Cl is actually benzylic because it is not connected directly to the benzene ring, but it is connected to the carbon which is connected to the benzene ring just outside the uh, carbon which is connected to benzene ring. So it is benzylic. So this is benzylic chloride. Okay. This is aromatic or aryl. Aromatic short. Uh, in short, we say aryl. And what about this iodide? Is it an aromatic or aliphatic? Is it vinylic? Is it allylic or is it primary? Is it secondary? If you have an alkyl halide, then you need to classify it further to as 1 degree, 2 degree, or 3 degree. Yeah. So is this aromatic? Yes or no? Is it connected to benzene?
Oh,
No. Right. It is not connected to benzene. It is connected to. It is not also connected to the carbon which is just outside the benzene. Instead, it is just on the next to next carbon. So it is just a normal carbon. Okay, so it is alkyl halide. Okay. And because this carbon alkyl halide can be further classified into primary, secondary, or tertiary. Okay. So this is primary. 1 degree because this carbon is connected to 1 degree. Right? Is it clear?
yes, sir.
Okay. So likewise, this is the basic classification. And apart from this, we have some preparation methods. So how do you prepare alkyl halides? How do you prepare them? What's the method of preparation of alkyl halide? What that method is called? You can tell me just one word. That will be sufficient. I need, but that should be related to this, so that there is one word which I want to hear from you people, and that will make me clear that oh, this is the method. So first of all, yeah,
Addition of halides.
addition of halides, yeah, somewhat it is similar. You are very close to the answer. Yeah, Absar, any idea? So first of all, you need to take alkane. for alkane should be appropriate. Suppose if you want to take ethyl chloride, you need to take ethane. Okay, if you want to make butyl chloride, okay, you can take butane. Methyl chloride, which is having one carbon, so you need to take methane. That is the first thing. Okay, and suppose if you whichever halide you want to connect, you can take it as halogen. Okay, is it clear? You can take it Cl2, Br2, right? And but will the reaction start on its own? Neha, will the reaction start on its own, or do we need to do something so that the reaction can start? Yeah, tell me. Yeah, Neha. You need to take some light, heat, which is a form of the energy. Clear? Okay, that so sometimes you will have h nu written. H nu is the energy of the photon, which is the particle of light, or you can have some sunlight somewhere it is written as sunlight, or somewhere it is written as UV light. Is it clear? You need to give some energy, okay, so that the bonds can break, okay, and the reaction can happen. Just by taking Cl2 and alkane, the reaction will not happen, right? So am I audible, Neha? So is
Yes,
this a, yeah,
earlier your voice was breaking up, sir.
yeah, okay, no problem. So this method is known as photohalogenation. Photohalogenation means you are doing the halogenation in the presence of light, right? So how do I convert how do I convert alkane to alkyl halide? By photohalogenation. You need to remember this thing. You take the alkane, you take the halogen, okay, you put sunlight, UV light, and you that is the source of energy, and that breaks the bond between the halogen, and that's how you can get the alkyl halide. Is it clear?
Yes, sir.
Yeah. Okay. So what's the shortcut trick? Shortcut trick is CH3H and Cl2 you can take, and just remove HCl. Actually, the sunlight which we are providing, that is giving the energy to break the CL bond. Okay. Right. Clear? So this is CH3, Cl, and HCl. This is one time, you can do it twice or thrice also. Okay. How can you do it twice? You can take Cl2, you can take chlorine and light again, and the reaction will happen one more time. So what will you will get? CH2, Cl2, and HCl. Right? Neha, am I audible now?
Yes, sir.
And you can do it thrice also. What you will get? CHCl3. What, there is a special common name for this CHCl3. Can you tell me? What's the common name for this? It's chloroform.
Chloroform.
Yeah, good. Chloroform. And it is used as an anesthetic. Okay.
Yes, sir.
So actually, yeah, so we can do the halogenation multiple times, but if nothing is mentioned, you can do it just one time. Okay. If nothing is given, just do it for one time, replace one hydrogen and put Cl. So this is monochloro derivative. This is dichloro derivative. This is trichloro derivative of methane because I put 3 chlorine, and this is tetrachloro derivative of methane, that is CCl, for carbon tetrachloride. Okay, clear?
Yes, sir.
So suppose if nothing is given, you will make only monochloro derivative. And suppose if you have butane, and if you react it with Cl2, sunlight, right? And how many monochloro derivatives you will get? Tell me. How many monochloro derivatives for butane you can get? Monochloro derivative means you will replace one hydrogen by chlorine. There are 10 hydrogens, so you can replace any one hydrogen by chlorine, and you need to tell me how many different structures will I get. It may appear difficult, but it's very easy. So you can give me your answer first. Yeah. So how many carbon atoms we are having? We are having 4 carbon atoms. Okay. But and how many hydrogens we are having? We are having 10 hydrogens. But all these 10 hydrogens are not different, right? Actually, you need to identify how many hydrogens are different. Okay, so you can check that these hydrogens are same. CH3 and CH3 both are same because one is on this side, another is on that side. And these hydrogens are also same. So you can take any one of them. Okay, though there are 10 hydrogen, the formula is C4H10, but all 10 are not different. So what you can do is either you can take any methyl group, the one which is at the corner, and you can take that hydrogen. And another is this. Okay, so the first one is going to be 1-chloro-butane, and the last one is going to be 2-chloro-butane. Okay, you will do the numbering from this side. Is it clear? Neha, is it clear or not? Okay, so so today
Yes.
actually running out of time. Yeah, I hope you understood. And
Yes,
just
sir.
okay, good. So let's have it in the regular class. Okay, we will discuss more new concepts. So let me end the class today because I'm having another class getting delayed. Okay, so bye bye. Take care, and do join our full year course. Okay, so let me in today's class. Bye.
Okay, sir.